Hey, my beautiful students. So we're back again, and I'm starting the second part of the ANOVA 1 factor screencast. And when we last left, or when we said goodbye in the last screencast, we were at this table. So this is a really, really nice summary table of ANOVA 1 factor. And we remind ourselves that ANOVA is hypothesis testing. So with hypothesis testing, we have a null hypothesis and we have the corresponding alternate hypothesis. We also have a alpha, or a level of significance, which is related to a confidence level. And we're going to need a calculated statistic that we're going to compare to a critical value. Or, well, in ANOVA 1 factor and 2 factor, actually, we only have one critical value. So that's very important. I know some of you are going to email me or send me a WhatsApp to ask me about this again, but there's only one critical value with ANOVA, which is a F upper value, because we're going to do a F test. So to do that F test, this is the formula that we're going to use. And so I've prepared a slide here where I'm just going to write a few things. Let's find my pen. So my null. And we haven't yet looked at an example, but this is what I want to see you guys starting to do. It would be mu is equal to mu2 is equal to mu3 for however many samples you have. And the number of groups is C, I'll remind you. And then my alternative or alternate hypothesis would naturally be not all groups. I told you I prefer not all groups are, let's erase that, not all groups are equal. So now we go on and we have a look at our F stat. So to calculate the F statistic, we've got to use the mean squares among in my numerator and the mean squares within in my denominator. And so we're looking at the variation that we see among the groups over the variation that we see within the groups, the total variation that we see within the groups. And then we have to calculate the F critical value. And to calculate the F critical value, we use the degrees of freedom associated to the mean squares among and the mean squares within. So we'll take the degrees of freedom for mean squares among in my numerator and the degrees of freedom for mean squares within in my denominator. And that is what we read off the F table. So I've got an F table here. And we then obviously look, we remember, I'll remind you, let me shift this properly. We have a couple of F tables. So you have to have a look. You've got to find the level of confidence that you want to use, or the level of significance, and you use the appropriate F table. And in the horizontal row above is my numerator, and in the vertical row descending is my denominator. And then the decision rule that we have to be aware of is if the F stat, so if the test statistic is greater than the F critical value, then we'll accept the null hypothesis, which states that all groups are equal. And if the calculated test statistic is less than my critical value, then we're going to reject the null hypothesis. So that is pretty simple, and we also know how to word that properly. You must remember that that counts about 4 marks in your exams, and I want to make sure, or I'll give you marks for saying everything that you need to say, and you need to say everything so that I know that you know what you're talking about. So you'll start concluding your hypothesis by saying at whatever level of significance or at whatever amount of confidence you have enough statistical evidence to either reject or accept the null hypothesis, which states, and then you need to say whatever it is that you're looking at. It's no good remembering it like parrot fashion, because I'm going to give you marks for your understanding. And then, of course, depending on whether you accepted or rejected the null hypothesis, you're going to say what you did to the alternate hypothesis. So that's the first part of ANOVA 1 factor. And that seems pretty simple, but the fun starts when we reject the null hypothesis. So I'm actually going to end the screencast here. I'm not going to discuss new work. I'll do the next screencast on what we do if we reject the null hypothesis. But before I end the screencast, I just want us to just recap. After we've stated the null hypothesis, we calculate the test statistic, calculate the test statistic, and then we determine the critical value. And to determine the F critical value, we're going to use the degrees of freedom. And then the decision rule we use if this value is greater than the critical value, then we will accept the null hypothesis. If that value is less, however, then we are going to reject the null hypothesis and we will accept the alternate hypothesis. So, if calculated greater than F stat, accept. And if F calculated is less than F stat, then we reject. And if we do reject, then we perform the next procedure, which we'll discuss in the next screencast.